Hello all, we'll be looking at pointers once again today, and this time using pointers with maths. We'll also look at how to add integers into pointers and why the result won't be as you'd quite expect it to be. We'll build a simple integer array, call it any name, we'll call this Jake, and this will hold 5 integers. Okay, on this computer each integer takes up 4 bytes of memory. They may take up to 2 or 4 bytes on the older computers. However, with the more modern ones, they may take 8 bytes. So it varies depending on the age of the computer. It doesn't matter too much if your results aren't exactly the same as my computer. Different computers would store integers differently. So we'll make a couple of pointers. We'll make a pointer peg0. This is going to be equal to the address of Jake0. So basically equal to the address of the first element. And we'll print it. Peg0 is that memory address. That will print memory address, which will print peg0, and then end line. So when we build and run this, it shows us peg0 is at the memory address FF08. So as we've built an array and each integer takes up 4 bytes, then we expect that the next pointer should be a memory address 4 from that. So if that pointer was 8, then we'd get 12, and the pointer after that would be 16. Then 1, and then this will point to the second element, and this to the third element. We'll see the results now when we print on screen. So basically printing out the memory address of each of these. Peg0 is at the location point FF00, and as we're storing integers which take up 4 bytes, the next location will be 4 away, so at FF04, and the next one FF08. So each integer takes up 4 bytes of memory of the computer. As we're building an array, each integer follows right after the other, and each element in the array is stored 4 bytes after the next. So each time you make an integer on your computer, it reserves 4 bytes of memory and nothing else can go inside it. So if we have peg0 and we set it to add 2 to this memory address, so plus equals 2, then print out the address of peg0 again, and what do we get? The previous address it was stored at was FF00. This time we've added 2. So logically we should get FF02. So let's see. Now the first element was stored at FF00, then FF04, then 08, and so on. Now we added 2 to the first element, FF00, so we should expect FF02. But the computer says peg0 is now at FF08. Basically what happened is that pointers don't work like our brain, and when you add integers to the pointer, it doesn't change the memory address of the pointer. It only changes the element it's pointing to. So when we had FF00 and added 2 to the pointer, it didn't change the memory address, but it took the pointer, added 2 to it, and then pointed to whatever is 2 elements away. So when you're working with maths and pointers, you don't change the memory address, but just the element it points to. If I type in peg0++, it won't change it from FF01, it would change it to FF04. It wouldn't change the memory address. It says if you're adding 1 to this pointer, you may want to point it to another one. So instead of changing the memory address, it changes the direction where it points. So anyway, that's how maths and pointers work, and the reason why the results may be different to your expectations. So thank you once again, and until next time, bye bye for now.